Hello everyone, this is Christian Janke. I'm an instructor and assistant professor at Embry-Riddle Aeronautical University's worldwide campus, and I want to welcome you to this massive open online course of the College of Aeronautics specifically on the subject of small unmanned aircraft systems. This module will have 3 lectures and cover several issues. First of all, we'll take a look at the National Airspace System, or NAS. We're going to look at the basics as to how it works, the classes of airspace, and how they relate to a small unmanned aircraft system or SUAS operator, specifically a hobbyist or recreational user. Furthermore, we will look at and discuss some of the basic do's and don'ts of recreational UAS operations in the NAS. And the point here more than anything is to have you to be part of the aviation safety culture, not part of the problem. The focus will be on how those airspace areas affect when, where and how you can operate. We also take a look at notice to airmen and other items that can pop up that you need to follow in order to be safe and successful as a good SUAS operator within the NAS. Part of that is a proper planning process. So we'll look at several of the easily accessible online applications such as Google Earth, skyvector.com or AirMap, all of which can help you better plan your operations. Also, we will take a short look on international examples of UAS regulations and a small glimpse into the future. Aviation has been built over decades on lessons learned and a cooperative approach. There's one thing at the end of the day that all of us can agree upon, be it pilots, instructors, airport managers, the FAA authority, or any other civil aviation authority supporting safe flight. A safety culture that continues to be the one that fosters safe flight for all involved, airborne or on the ground. All of you, by taking this course, are part of this movement. First, take a look at how the NAS works. There's a very good and short Federal Aviation Administration video on that topic. Let's have a look.
The FAA's mission is to provide the safest, most efficient aerospace system in the world. We do. The FAA controls thousands of planes in the air at once, moving hundreds of millions of passengers a year. Add in billions of dollars in air cargo and hundreds of thousands of private pilots, and you have a big challenge. Here's how it's handled. As passengers board a plane, the pilot files a flight plan with an air traffic controller and gets weather information. The plane won't taxi until a ground controller, keeping track of planes all over the airport, okays it.
Delta 2412, push approved, advise taxi.
That controller will direct the plane along taxiways to the runway, where a local controller, also in the tower, takes over. The local controller will safely guide the plane through takeoff and over a set course just beyond the airport's boundaries, where a TRACON controller takes over. The Terminal Radar Approach Control, or TRACON, may be at an airport or at another location that manages the approach and departure for many airports. Unlike tower controllers, TRACON controllers work exclusively from radar and have no windows to see planes, which could be more than 100 miles away. These controllers keep planes separated within about 50 miles of an airport's airspace at altitudes up to 17,000 feet. Beyond that, en route controllers manage the flights. En route controllers work at one of 21 air route traffic control centers across the country. Each en route center is responsible for defined areas of airspace with multiple sectors inside each center's airspace. Even though the sky seems boundless, teams of en route controllers keep planes flying in lines following fixed ground locations. Pilots stay fully advised as communications are handed off from controller to controller. As tower, TRACON, and en route controllers focus on planes, management teams help controllers at the Air Traffic Control System Command Center see the big picture. Command center controllers don't speak directly to pilots. Instead, they coordinate nationally with airlines, fellow controllers, the military, and other users of the airspace to keep things moving safely and efficiently. As a plane descends, it will return to TRACON controllers, who steer it into line with other aircraft approaching the airport from different directions. The local tower controller takes over for the landing, and a ground controller guides the plane back to the gate. That's just a few of the more than 15,000 air traffic controllers keeping America's skies the safest and most efficient in the world.
Now we'll go ahead and move to the different types of airspace. Now something to keep in mind as we talk about airspace. There are two major types of airspace here in the United States and all over the world. Controlled with specific dimension, including horizontal and vertical boundaries, and uncontrolled, basically everything else that isn't controlled. And that uncontrolled area has restrictions and limitations in specific areas in some parts of the United States based on population and other factors. But we are going to look at each of those airspace types that are controlled and Class G airspace, which falls under the uncontrolled airspace, and go through each of those and how they influence how you can operate as an SUAS operator. In your optional reading for this module, you will see that this great design is delivered by AOPA, the Aircraft Owners and Pilots Association. It's called Airspace at a Glance. This diagram is designed for pilots who are going to be flying in, around and through such airspace, depending on the capability of the pilot and the capability of the aircraft and the equipment that it carries. We'll be doing a little bit of a different approach in this module. I'll be talking about these airspaces from a much broader perspective, what they're used for, some of their limitations, and give you an idea of why it is that you have to avoid them. Specifically why the FAA has set rules for no closer than 5 miles to an airport, airfield or heliport without previous coordination. So let's go ahead and get started. Let's go to Class A. Class A airspace is found 18,000 to 60,000 feet, mean sea level well above that of recreational, hobby users, which is mostly limited to 400 feet above ground level. All of the jetways are in Class A airspace. Class A airspace is primarily used by jets and airliners traveling over long distances between major cities. All flights in Class A airspace are conducted under instrument flight rules. Therefore, pilots must hold an instrument rating and be on an active IFR flight plan. Pilots must obtain a clearance from ATC before entering Class A airspace and maintain radio contact with ATC at all times. Also, all aircraft must be equipped with an altitude encoding transponder to provide location and altitude data to ATC radar equipment. Now, don't confuse instrument flight rules or IFR to mean bad weather. It means positive control in Class A airspace is an example of incredibly well-orchestrated positive control of aircraft and coordination across the country in the NAS. When you're flying a commercial airliner, the chances are high that you're above 18,000 feet and you're going to be flying in Class A airspace. Again though, this is not an issue for hobby or recreational users. Class B airspace is found around the busiest of airport. LAX or Los Angeles or Chicago O'Hare or RD are examples of Class B airspace with crowded operations and constant flights in and out. Class C airspace includes congested airports, still with a lot of traffic in and out, but much less than Class B airspace. Monterey and Spokane International are examples of Class C airspace. Class D airspace, or an easy way to remember D for directed, are smaller airfields that have a control tower but don't have the traffic load of a Class C or a Class B airspace. Examples of that would be Grant County International in Moses Lake, Washington, and Easton Newman in Maryland. Here's an interesting twist. When a Class D airspace control tower shuts down for the night, the airspace where the tower is located and the airfield that it is on falls under Class E, Echo airspace. Now that may sound a little bit confusing at first, but here's a way to remember that. Think of Class E airspace as enclosure, and it encloses all of the airspace except Class A. So all that happens in the night when the tower closes down. Class D airspace goes away and that area is filled back in with Class E. When the tower opens again the next day, Class E in that area becomes Class D again. So remember, E for enclosure. Class G Golf airspace is oftentimes good to go. Class G airspace is the only uncontrolled airspace in the national airspace system. Now, Class G airspace doesn't mean you can go out and do whatever you want to do. It just means that when you're flying out, you're on your own. Some people call it the Wild West of airspace, and that you can go out on the range and fly and be left alone and you don't have to talk to anybody. You just need to follow some basic rules of visual distances to clouds and other aircraft, also known as see and avoid, and you're good to go. Special use airspace includes a lot of restricted airspace around the country. Types of special use airspace include prohibited areas, restricted areas, warning areas, military operation areas, alert areas, and controlled firing areas. So for example, the left graphic here shows Boardman military operating area and the restricted area in which you are not allowed to fly. To the right, this is a general graphic provided by the Air Force and their R2508 complex at Edwards Air Force Base, also a restricted area. If you are a certificated pilot and you have a good understanding of restricted airspace, you will know when restricted airspace can be flown under, because the altitude may not go to the surface for restriction. But if you are not a certificated pilot, if you're not familiar on how to read the restricted area graphics, it's best to avoid them completely and check with a pilot or a local airport operator and determine what the reality is. And so you will have a better understanding of what you can do and can't do. But as a rule of thumb, restricted area is a no-go. Now also on top of this is what we call NOTAM, which stands for Notice to Airmen, and TFR, which stands for Temporary Flight Restrictions. And NOTAM is very important because it's going to give you notice containing information that is not out in advance by other publications. So in other words, this is going to be the type of advisories that update you with something that isn't on the map or on a chart or in a booklet that was printed 2 or 3 months ago or even years ago. Now it's important to look at NOTAMs because NOTAMs, a special kind, is a TFR. And TFRs are going to tell you where you can fly at all and the reason for that TFR. So for example, you might have a hazardous condition, you might have a special event, the president is in town, you may have an entire area for an airspace that needs to be shut down. The TFR is going to tell you that, and you are going to find a TFR under your NOTAM alerts. At this stage, you may realize that the restrictions, no-goes and confinements that can influence or prevent your SUAS operation, may it be commercial or private, can come from the airspace situation and from the ground status. So if you ask yourself, can I fly here or there? There are many types of airspace and ground-related restrictions in the United States. As you have learned, restrictions that commonly affect SUAS flights can be restricted airspace or temporary flight restrictions. But we need to talk also about other conditions and restrictions. For example, stadiums, sporting events and wildfires. So the rules for stadiums and sporting events are that flying SUAS in and around stadiums is prohibited starting 1 hour before and ending 1 hour after the scheduled event. And for all times in that time zone goes that it's prohibited within a radius of 3 nautical miles of the stadium or venue. Wildfires. It's illegal to fly your SUAS in or around a wildfire, especially a wildfire firefighting operation. Depending on the environment and the legal system, there can be also restrictions towards land ownership, national parks, hospitals, power plants, schools or prisons. All of the mentioned restrictions can be static, like for a prison, or dynamic, like for example a VIP visit or a major event. In this lecture, you have learned about airspace classes in the National Airspace System and how they relate to an unmanned aircraft system. Also, you learned about many restrictions that are important to consider when operating SUAS. We concentrated on the NAS in the United States. If you're taking this massive open online course from a country outside the United States, there will be many similarities and also differences. Now join me for lecture 2 to go one step further towards safe SUAS operation.